Hi, in this video we are going to work on expanding brackets. Now if we have something like 2 times in brackets 3 plus 5, generally we work out the operation in between brackets, and we go like 2 times 3 plus 5 is 8, and then we end up with 16. But it is also possible to multiply the numbers in the brackets by 2. So we can, as a second way, go like 2 times 3 add 2 times 5, whereas 2 times 3 is 6 and 2 times 5 is 10, so we're going to end up with 16 again, right? So this is called as distributive property for addition, right? Instead of working out the addition inside the brackets first, you can distribute 2 and multiply it with each number inside the brackets and find out the same answer, right? This is called as a distributive property, so it goes like 2 times 3 and 2 times 5. We are going to use the distributive property while expanding brackets in algebra. Let's see an example. Right, in this one the instruction or the question, the root of the question will be expand, right? This means you're going to distribute 3 within the terms inside the bracket. So it's going to be 3 times 5, which is 15, so that's going to be 15x, and then it's going to be 3 times 2, which is 6. So basically this is how you expand brackets. It's 3 times 5x, which is 15x, 3 times 2, which is 6, and well, it is 5x plus 2 here, and you're multiplying with a positive number, so this sign in between does not change, right? Let's see another example. Let's have 5 multiplied by 2m minus 7. Now in this one we're going to do the same thing. 5 times 2 is 10, so it's going to be 10m. 5 times minus 7 is minus 35, so I write 10m minus 35. What happens if we multiply it with a negative number? So let's say minus 4 multiplied by y minus 3, right? So it's minus 4 times all these. So minus 4 times y is minus 4y, and minus 4 times minus 3, well, 4 times 3 is 12, minus times minus is plus, so that's what I'm going to write here. So the expanded form will be minus 4y plus 12. What happens if I have an unknown outside the brackets? So basically the same idea applies. M times 3n, it's going to be 3mn. I could have written 3nm, which is the same thing technically speaking, but we prefer the alphabetical order generally speaking. So it's 3 times m times n. And another thing is that we have to write the coefficient, the number in the front, in the beginning all the time. So it's not like m3n, it is not n3m, it is not nm3 or anything of this sort. Generally we prefer the number in the front and then alphabetical order if there are more than one unknown. Right, so that's going to be 3mn. And then the second one is that m times minus 1, well, 1 times m is m, minus, and well, m doesn't have a sign here, right? It's not minus or anything, so I will consider putting a minus sign here. So it's going to be 3mn minus m. I may have, let's say, 5x multiplied by 3x plus 4, right? In that case, 5x times 3x, I multiply numbers separately. 5 times 3 is 15, x times x will give me x squared, and I'll also multiply 5x and 4, so that's going to be 5 times 4, 20x. So this is how I expand brackets like this. Another example, let's go on with 3a squared multiplied by 4a plus 7. So 3a squared times 4a, 3 times 4 is 12, a squared times a to the power of 1, right? So it's going to be a cubed. And 3a squared times 7, well, that's going to be 3 times 7, 21. And I'm going to copy paste a squared because there is no a term in 7, right? So it's 12a cubed plus 21a squared. That's the expanded form. One last example. Let's say I have 5x multiplied by 2x squared minus 7x plus 5. So this in brackets is called as a quadratic expression, right? We have 3 terms here, with the first term having the square of x, and there's nothing different that I will do. I'm going to use the distributive property to expand this bracket. So it's 5 times 2, 10, x times x squared, x cubed. This one, right? 5 times minus 7 is minus 35. X times x is x squared. And the last one, 5 times 5 is 25. And there is no x term in here, so it's going to be 25x only. This is how I expand these brackets. Now notice here that none of these expanded forms have any sort of like terms. This is 15x squared plus 20x, so I can't add them. This is not equal to 35x or 35x squared or whatsoever. Right here, this is 12a cubed and 21a squared. These are unlike terms. You cannot add them. Here, these 3 terms are unlike terms each, so you can't add or take them away. It's just this, right? And this is also a clue. The question only asks you to expand. If simplification would be involved, the question would ask you that. The question instead would say expand and simplify, right? But here we don't have it, so that's also a clue for you, a hint for you, saying that you cannot add them, you can't take them away, you just write them as is. Now let's look at this example. Here we have 2 expansions, right? And the question says expand and simplify. Obviously, we're going to get some like terms here after expansion so that we can simplify. So let's start. It's 4 times x, which is 4x, and it is 4 times 7, which is 28. So I copy paste this plus here. 3 times 2x is 6x, and 3 times negative 3 is negative 9, right? So it's 6x minus 9, basically. So you can see now that 4x and 6x are like terms, whereas 28 and minus 9 are like terms. So 4x plus 6x will be 10x, and 28 minus 9 will be plus 19. So it's going to be 10x plus 19. This is the simplest form. Another example. I will start with the first expansion. It's going to be 3 times 2x, which is 6x, and 3 times minus 5 is minus 15. Now here I have minus 2 times 4x plus 1. So it's going to be minus 2 times 4 minus 8x, and minus 2 times 1 minus 2. So be very careful with the sign. You have to be multiplying with minus 2 here, right? And then you can see the like terms, 6x and minus 8x are like terms, so it's going to be 6x minus 8x minus 2x, and minus 15 minus 2 are like terms, so it's going to be minus 17. This is the simplest form. Now is your turn. Please solve these questions on your book and submit your answers online. Thanks for watching.